I will be discussing the problem unique paths. The problem statement says there is a robot on an M into N grid. The robot is initially located at the top left corner, that is grid 0, 0. The robot tries to move to the bottom right corner, grid M minus 1, N minus 1. The robot can only move either down or right at any point in time. Given the two integers M and N, return the number of possible unique paths that the robot can take to reach the bottom right corner. The test cases are generated so that the answer will be less than or equal to 2 into 10 raised to 9. Uh, so if we are doing DFS recursively, one thing we can do is have a cache for every row, column or position for the result. For each position, we are actually calculating the number of ways we can reach the destination. If we can compute that for every single square, then we can compute that for the original square too. The solution code uses 1D dynamic programming where row of j represents the number of ways to reach the bottom right cell from the current row and column j. We start with a row of all ones because the entire last row has only one path. Move right, then for each row above it, build a new row. New row of j equals the sum of the cell to the right, new row of j plus 1, and the cell below, row of j, because those are the possible two moves. Those are the two possible moves. We iterate this for all m minus 1 rows, updating row each time. The answer ends up at row of 0, representing the number of ways from the top left corner. The time complexity of this solution is big O of m into n, and space complexity is big O of n, where the patterns which is observed while solving this problem is first is minimum path sum, second is triangle, third is dungeon game, fourth is maximal square, fifth is minimum falling path sum, the next is minimum falling path sum 2. The next one is cherry pickup 2, and then the last one is unique paths 3, where this is a more complex version of the problem statement. So I was actually, while I was solving this problem, I stumbled upon a YouTube video where the YouTube video was continuously emphasizing on only one statement, where it is not necessary to memorize the problems, it is necessary to memorize the patterns, so that whenever the complexity of any problem would be arising, then uh, I can actually memorize those patterns again and again, and then I'll be able to solve that problem.